Hi everyone, welcome back. In this video I'm going to run through a quick analysis on that impact test data I got in the last video. So to start off I'll hit the load button, and to load up all the data from one session you simply click on the folder which is timestamped based on when you started logging. Click on add and that'll load all the data from that session. Hit done. Keep an eye on this please wait logo up here. And that should be ready. Okay, so you can, on the time waveform plots on the left, you can see the 4 impact tests. And you can see the peak hold plots on the right. So all these settings are based on how we had it set up when I started logging. So I'll make a few changes to that. First up, I'll get rid of the peak hold plots because I just want to look at one current spectrum at a time. And I'll add the zoomed time plot. And that will show another plot with 4 seconds of the time waveform. And at the moment I'll leave it on quarter hertz frequency resolution, which is based on a 4-second window. So because the zoomed time plots are going to add another 5 plots, that'll give us 15 plots. I'll change it to 3 columns. And I might have to rescale the y-axis as well. I'll just see how this looks. Okay, so if you click on any of these locations on the time waveform, you get the zoomed time plot from that period. I'll just rescale all the time waveform plots to about, let's try 0.2 millimeters a second, just so that we can see the phase. Okay, so that's the time waveform for all 2 minutes of data, or just more than 2 minutes. And this is the second plot here is a 4-second window around this cursor bar here. So we can click on that to move it. We can also drag it. And the graphics is taking a bit longer at the moment because I'm recording from the screen. And you can also drag it a small amount in this zoomed plot. So what I'm trying to do there is get the cursor lined up with the top of this wave plot there. You can see in all 3 of the first 3 channels, that's channel 1 there, channel 2 here, and channel 3 there, they're in phase because this cursor is in the same location. It lines up nicely with the crest there. So that tells us that at this frequency, which is dominating at the moment, the 3 vertical channels are all in phase. That tells us that it must be the bounce mode. And we can also see from channel 4 here and 5 here that there's not much going on horizontally or axially. So that tells me fairly clearly that this natural frequency here at just below 8 Hertz is the first bounce mode. So the plate is moving vertically. Now if we look at what happens right when I do the impact, you can see there's a second frequency picking up there, and that one decays away a fair bit quicker. And we'll figure out what that one is from one of the other impacts. Okay, let's go to the second impact, which is the horizontal one in the middle. So channel 4 is a horizontal channel. You can see it's actually vibrating more on channel 1, 2, and 3. So that's because the system is not quite symmetrical. So even though this is nominally a horizontal mode, it's actually rocking a fair bit, and the vertical vibration amplitude where the sensors are located is actually higher than the horizontal one, except at this first mode down at just above 2 hertz. It looks like about 2.5 hertz. At that frequency, horizontal is dominating, and there's also a little bit of vertical. So that would be the first horizontal mode, equivalent to the pure translation mode if the springs were set up symmetrically. Um, and this mode here at about just under 11 hertz would be the second horizontal mode, um, which is, so that's rotation about the axial axis. Um, and that's, yeah, because it's essentially rotating about the axis, the vertical vibration is actually higher at that frequency. Um, so I'll go to the third impact, which is the second horizontal one on the outer edge of the plate. And you'll notice that I think it's this frequency here, maybe around 6 hertz, or maybe this one at 7 hertz picks up. Um, let's see which one it is. Yeah, it's this one here at about 6 hertz that you can see on channel 4 on the spectrum. So that one there would be the twist mode. So that is dominated by horizontal movement. There's a little bit of axial and very little vertical motion. And yeah, when I did the impact in the center of the plate, the horizontal impact, it didn't excite that one because there's no displacement at that location for that mode shape. But if you do the horizontal impact on the outer corner, it does excite that mode shape. And that's, I guess, an important lesson for when you do impact tests. You can miss important natural frequencies or mode shapes if you do the impact in the wrong location. So a good rule of thumb is either to impact slightly off center or on the outer corner, or maybe impact in two locations. So we've identified the vertical mode, the twist mode, the two horizontal modes, um, and our final impact was the one in the axial direction, which is this fourth impact. You can see here channel 5 is picking up at just a little bit above 3 hertz. So that's again close to being a purely translational mode. There's very little horizontal and very little vertical movement. So that's the one you could see visually when I did the axial impact. That's that plate sliding back and forth. Um, and the other mode that picked up is this horizontal one at 14 hertz, which is the highest frequency out of the six. And that's what I'd call the nodding mode. So the channel 1 and 2 will be out of phase for that mode. Um, yeah, so let me just demonstrate that. Okay, what I might do is change it to a 1 second window. Just to make it a bit clearer what's happening with this 14 hertz mode. There we go. So I'll just drag the plot a little bit to the left. Okay, so you can see from the spectrum for channel 1, 2, and 3 that the 14 hertz mode is dominating. So we can be fairly confident because the FFT and the time waveform is in acceleration units. We can be fairly certain that this sine wave we're looking at is the one at 14 hertz. And as you can see, channel 1 and 2 are out of phase because the valley here lines up with the peak in the time waveform here. but 2 and 3 are in phase. So that makes sense because channel 2 and 3 are vertical at the same end. So this is what I'd call a nodding mode about a horizontal axis. So that's all 6 vibration natural frequencies. And even though I only had 5 sensors, I was able, with a few assumptions, to get an idea of what the mode shape is.